You probably noticed when we had our chart for operating with monomials that we left off division. This whole chapter is about factoring, and division is essentially the operation that goes with that. From that, you could probably guess that when we are dividing monomials, you could probably guess that we would be dividing the coefficients and subtracting the exponents. And to a certain extent, you would be correct. However, some problems get a little bit more complicated. This is an easy problem. 10x to the third, negative 10x to the third, y to the fourth, divided by 2x y squared. By expanding this, you can see that this is the same as negative 5 times 2 times x times x times x times y times y times y times y, extend that line, over 2 times x times y times y. By dropping out the ones, we can prove that what this equals is negative 5x squared y squared. We did, in fact, divide the coefficients and subtract the exponents. Remember, this exponent is 1. However, with division, it doesn't always come out that easily. I want to move to another page so that you can see this. What if the problem had been 2x, squared y over negative 10x y to the third? Again, we could open up that accordion, 2 times x times y, and then negative 5 times 2 times x times y times y times y. And you can see that the 2's cancel out, an x cancels out, a y cancels out. And then you have to say, what is this? Well, on the top I have an x. On the bottom I have negative 5y squared. Remember that a positive divided by a negative always equals a negative, so when it comes out negative, we put the negative out front because the whole fraction is negative. That's a little important thing, but a little detail, but you can get that. So it's negative x over 5y squared. Exactly what happened here? We did sort of divide the coefficients, but really what we did was reduce the fraction. 2/10 became 1/5. And we subtracted the exponents, but notice that the x's landed on top and the y's landed on the bottom. Why did that happen? Well, if you look back here, 3, there were more 3's, more y's. The big exponent for y was bigger than the exponent on the top. So since there were more y's on the bottom to begin with, that's why the leftovers ended up on the bottom. Since there were more x's on the top, that's why the leftovers ended up on the top. So really what we're doing is reduce the coefficients and subtract the exponents, but remember, in the answer, it goes, the answer goes in the part of the fraction where the bigger exponent was originally. Let's do a few more examples. The examples that were in your book are all pretty easy, but let's say 35 x to the third, y to the sixth, over 56 x to the 5th y. Okay, so we want to reduce our fraction. What is the biggest number that goes into 35 and 56? And I know you all know that that is 7. So this reduces to 5/8. 5 minus 3 is 2, and since the exponent of x is bigger on the bottom, we're going to put it on the bottom. 6 minus 1 is 5. Since there are more y's on the top, we're going to put this here. Ta-da! What if it were, let's see, negative 6a b to the 3rd over 12a b to the 5th. Again, what I like to do is just draw my fraction bar. I can see that different signs are going to give a negative, so the negative goes out here. 6 over 12 reduces to 1 over 2. I don't need to put the 1 on the top, but I can if I want to. These cancel out altogether. 1 minus 1 is 0, and anything to the 0 power is 1, so I don't even have to include those. And then I say I have b to the 2nd. Actually, I said I didn't need that 1, but when everything cancels out on the top, you do need the 1, because without the 1, you get a very different fraction. 1/2 is a different number than 2 over 1. The final kind of example I'm going to do are ones that have the me first kind of exponent. In other words, if I have 3 x to the 3rd over 3x in parentheses squared. Remember, the bottom is the kind of exponent that you need to take care of first. So this is 3x to the 3rd over 3 squared is 9. X to the 2 times 1 is x squared. Now I reduce my fraction. I get 1/3. And it's going to be x on the top, or x over 3. So don't forget you have to do these coefficients. And I think also in your homework there are a couple of problems where there are numbers raised to a power. Just like if I say 10 to the 3rd divided by 10 to the 6th. Notice that the 10s aren't coefficients, they're actually the bases. This means 10 times 10 times 10. And this means 10 times 10 times 10 times 10 times 10 times 10. So these cancel, and you get 1 over a 1 with 3 zeros, otherwise known as 1,000. You could say that this is 1 over 10 to the 3rd when we subtract these exponents, but then you do need to call it 1 over 1,000. The final kind of problems that are in your homework tonight say find the missing factor. Usually I find the kids find this very intuitively easy to understand. 48, x to the 3rd, y to the 2nd, z to the 4th is equal to 3xy squared times what? They say find the missing factor. Oh, actually, there's a z in here. So you could divide the 48 by the 3xy squared z and get your answer. Or else you could just look and say 3 times what is 48. You can just, without even doing that. Some kids like to divide, but I like to just say 3 times 16 would give me 48. I've got x to the 3rd here, and one of them here, which means I'm missing 2. Y to the 2nd, I'm good. And I need 4 z's, and I've only got 1 so far, so it's got to be z to the 3rd. So I think that that's all you really need to know in order to do your homework. And I will be emailing you exactly what that assignment is, though I believe it's page 192, 3 to 43, 3 to 43, multiples of 3. Good luck!